So if you give the assignment, so whatever will be targeted the data. If it is not given by data should be lost. So what has you? The data cannot be received. So what would happen again? The second will be retransmission. What will do? Retransmission. Okay. So this one is the content. Okay. The data and it should be given to the receiver. This frame should be converted into what? Package. What contains? Package. Package which layer? Package which layer, ma? What? Layer. So here provided by the network layer. So in these services, note down the three services. Services provide to the network layer. Acknowledgeable connectionless service. So there is a no connection between sender to receiver. There is a no acknowledgement given to the receiver. Receiver అనేవాడు నాకు acknowledgement ఇవ్వలేదు. Acknowledgement ఇవ్వలేదు. So what is second one is acknowledge connectionless service. So connectionless, what is connectionless service? There is a no connection between sender to receiver. This is the wireless transmission. Which media? Media. What is the wireless media? Transmission media, how many types? How many types, ma? Two types. What are the two types? Wide media, wireless media. Wide media, wireless media. The wide media we can also call as what? Guided media. ఏమంటారు? Guided media. Wireless media, unguided media. Unguided. The name itself will indicate unguided. There is no directions. So you should be transmit the data in the form of air. Next one is acknowledge connection oriented service. It should be given acknowledgement. And the sender sending the data to the receiver can give the acknowledgement. That is a reliable transmission. So here they can have a connection oriented. So connection oriented and connectionless. That comes your fourth unit, fifth unit. Transport layer low. One of the topic is there. So connection oriented and connectionless. Compare connectionless and connection oriented, or differentiate between connection oriented and connectionless. So here there is a connection between sender to receiver, that is called connection oriented. There is no connection between sender to receiver, that is called connectionless oriented service. Acknowledge connectionless service. For example, there is no acknowledgement from the whom receiver. What will happen? The source sending the independent frame to the destination. So whether the frame will be reached or doesn't reach. Second is here, if the frame is lost, third point, if the frame is lost, there is no attempt to make to detect the loss of the frame. The sender sending the data, then message పంపించాను. So whether the message will be reached to the particular receiver or not. Hi and పంపించాను కానీ రిప్లై రాలేదు. అంటే what will happen? Whether the message will be reached or doesn't reach. For example, I have sent the amount to the particular amount. Receiver 1,000 పంపించాను అందుకు. నాకు రిసీవర్ ఏం చేయాలి? ఐ రిసీవ్డ్ అమౌంట్. ఏం చేయాలి మనం? రిసీవ్డ్ అమౌంట్, థ్యాంక్ యూ అని మిస్టర్ రావాలి. కానీ మిస్టర్ రాలేదు. వాట్ మీన్స్ the amount cannot be received. So that kind of information means this example. Sender sending the data to the receiver. Acknowledgement. ఏమి ఇయ్యాలమ్మా? Acknowledgement. ఇయ్యలేదనుకుంటే ఏమనుకుంటాము? The data cannot be reached successfully. Okay, these are issues. Okay. See here, acknowledgement connectionless service. So acknowledgement connectionless means sender sending the data to the receiver. So receiver should give the acknowledgement to the sender. So means there is a connection oriented service. There is a guarantee of data. It should be have a reliable transmission successfully. డేటా అనేది రిసీవర్ కు రీచ్ అయింది. ఏం అర్థం చేసుకుంటాం మనం? డేటా షుడ్ బి రీచ్ టు ది హోమ్ రిసీవర్. సో రిసీవర్ షుడ్ గివ్ ఏ అక్నాలెడ్జ్మెంట్. ఓకే, see, the receiver send the acknowledgement back to the sender. Back to the sender. I receive your data. So thank you. So I am giving a acknowledgement. Acknowledgement connection oriented. So connection oriented means is a connection oriented service. Before that, connectionless service. Adi connectionless service, unguided we are using. Here we are using what? Guided media. Em use chestunnamma ikkada? Guided media. So guided media lo em untadi? There is a connection between sender to receiver, node to node, device to device. So data will be sender sending the data to the receiver. It should give a acknowledgement. Here, second, you see this point. The guarantee that each frame received exactly the received in the right order. So what will happen? The exact data will be sending to the receiver. The receiver give a acknowledgement that is called a connection oriented. Connectionless sometimes data will be lost. Sometimes what will happen? Data will be lost due to noise, due to what you call collision. What will happen? Data will be lost in a particular media. Where the data will be lost, we cannot be identified. See, morning class. Okay. Framing. So framing, what will happen? It should be have a which layer, the data given to the which layer? Network layer. The framing contain what? Data. Sequence of data. It should be contain header and tailor. And here, this will be have some mechanisms. First one is character. First one is what? Character. Note down this. Everyone note down. Note this last. కనిపిస్తుందమ్మా? Visible is visible. Okay. Character count, byte stuffing, bit stuffing, and last one is physical layer coding violation. The morning class lo adugutanu ivanni. Okay, what are the framing techniques? Character count, byte stuffing, bit stuffing, physical layer coding violations. Character count, the name itself, character count. How many characters are there in your frame? They can indicate. That is called character count. Byte stuffing. The byte stuffing means we'll be adding some stuffing, adding the bits. What will adding here? Characters DLE, STX, DLE, ETX. And be added 0. After 1 added the 0 added. Em added the okay. Coding violations. So physical layer code of signals should be high indicate 1, low indicate 0. See example here. So character count 5. So you should be indicate what? 5. So here next one frame 1, frame 2, frame 3. If you indicate, for example here 1, 2, 3, 4. So if you indicate 7, why indicate error? 7 unnaya? 1, 2, 3. So count it. 1, 2, 3, 4, 5. Count em. So error. It should error. So character count and in the number of characters in a frame that will indicate what? any characters indicate. Okay. Flag byte stuffing. So flag byte stuffing, we are adding some DLSTX, DLE, ETX. See example here. Okay. So here they indicate like this. ESC will be added. A flag bits. So some books will be given like this also. Okay. You're not there. Will be given DLSTX. Payroll for the 4 books will be given DLSTX and DLE ETX. So here they will be given ECX. So here A is there, B is there. In between, what will happen? We added the flag. Okay. Here, for bit stuffing. Bit stuffing. See here. Oh, okay. How many ones? 1, 2, 3, 4, 5. After 5 consecutive ones, bit stuffing. ఏమంటే దీన్ని బిట్ అమ్మది బైట్ స్టఫింగ్. This is what? Byte stuffing. Okay. Adding. We are adding the extra bits. This is the physical layer violation. So here, one bit is indicate what? One bit is indicate what? Low. Zero indicate what? One bit is indicate what? High. Zero is indicate what? Low. So morning we just now indicate wave. The data can be indicate a P. High value is indicate what? 1. Low indicate what? 0. అంటే పైన ఉన్న వాల్యూ ఏమంటాం మనం 1. The wave indicate what? 0. 0 is nothing but what? Low. Okay. Techniques, methods, problem solving morning class should be have fresh mind. So we'll solve the problems. So now theory here today, error control. So error control, what will happen? Error control can what will happen? It can do the error correction and the sender send data to the receiver, whether data will be reached to the particular receiver or not. Exact data is there or not. If it is contain error means what? Error content, sorry. What? There is a no use. If it is there is a no error means the exact data will be. Next, one more. Flow control. Okay. So what is the flow control? The sender want to transmit the frames. Sender want to transmit the frames faster than receiver can accept them. Morning I told, I want to receive your data. Only we need to send the data. The receiver capacity is less, but will be sending more fast. What will happen? The data will be long. Into controlling our data, we need mechanism. నేను క్లాస్ చెప్తున్నా అనుకోండి, ఫర్ ఎగ్జాంపుల్ ఐఎమ్ సెండర్, రిసీవర్ అనే వాళ్ళు స్లో ఉన్నారు అనుకోండి, ఏమైతే స్లో చెప్పి బ్యాలెన్స్ అంటే దే కెన్ అండర్స్టూడ్. ఓకే. అండ్ ఎర్రర్ డిటెక్షన్ అండ్ ఎర్రర్ కరెక్షన్. వాట్ ఈస్ ఎర్రర్ డిటెక్షన్, ఎర్రర్ కరెక్షన్? ఏం చేస్తామా? షుడ్ బి డిటెక్ట్ ద ఎర్రర్స్. వాట్ ఈస్ కరెక్షన్? కరెక్ట్ ద ఎర్రర్స్. ఓకే. So error correction, one of the mechanism is what? Humming code. So make a note. Error correction, error detect. Make a meeting is error error correction mechanism, error control mechanism. Put subheading is error correction and error detection. Error correction method is what? Humming code. First one is single bit error. Okay. Single bit error. Single bit ante morning చెప్పాను కదా, 0 can be transmitted to the 1. So automatically it should be detected by error. So what we'll do, we need to correct the errors. So 1 as a, we can need to change as 0. So one more mechanism is humming code. So what is the use of humming code? To correct the errors. ఏం చేస్తున్నాం humming code? To correct the errors. So tomorrow we will solve these problems. Okay, morning class. Error detecting. Error detecting, we can use, what is the mechanism here? Morning I told. What is CRC? Cyclic redundancy check. So cyclic redundancy check, we can do the division operation. Which operation? Division operation. So they can identify the errors with the help of the victim mechanism CRC, cyclic redundancy check. What is the redundancy? Redundancy nothing but extra bits. Redundancy nothing but what? Extra bits. Okay. So this is will be by tomorrow. Okay. Once you check your syllabus, Amma, syllabus check చేసుకోండి. First, we have discussed design issues of data link layer. Okay. Check చేసుకోండి ఒకసారి syllabus. Framing is discussed. Okay. Flow control, these are comes under design issues. Okay. Error control, error detection, by tomorrow we'll discuss the solving problem. Okay. Now, What are the services provided by network layer? We discuss. Now today class, afternoon, we'll discuss what? Sliding window protocols. Okay. Flow control mechanisms. After that, we need to go for the medium access control. So these are topics we'll discuss. And by tomorrow, remaining error correction, error detection, and TDMA, that will be covered by afternoon session. See, data link layer, there are two sublayers. One is logical link control. Second one is medium access control. Inanamma. Afternoon కాబట్టి కొంచెం క్లాస్ ఇంట్రెస్ట్ రాకుండా కానీ ఇంట్రెస్ట్ వచ్చేలా చూసుకోండి. ఓకే, కొంచెం నిద్ర పోకండి. ఓకే, there are two sublayers here. Note down. నేను రేపు అడుగుతాను కంపల్సరీ క్లాస్లో అందరి ముంగట. Logical link control. Second one is medium access control. There are two sublayers. So here, transmission media that comes under the part of physical layer. So this physical layer above layer is what? Data link layer. The data link layer too should be contained the medium access control and logical control. So here in your syllabus, third unit, we have a MAC, medium access control. Now, put subheading is flow control. Put subheading is flow control. Flow control. So in this flow control, these are protocols. Stop and wait, go back and selective repeat, sliding window protocol. So this exam point of view, they will ask, okay, 6 marks, okay, either 12 marks. Okay. How many marks you are? 10 marks. Total 14. Long question, how many? 14. 14. So in the 14, sometimes what will happen? They will ask a question, explain about selective repeat ARQ and go back in. So or they will ask A and B bit. So what is A bit? Sliding window protocol. B bit is go back in. So very easy topic. Okay. Just you need to draw the diagrams. So if you draw the diagrams, sender and receiver, just data, how to data will be transmitted. So you'll get easy to 7 marks. ఒకవేళ ఎగ్జామ్ పాయింట్ ఆఫ్ లో స్లైడింగ్ విండో ప్రోటోకాల్ కానీ గో బ్యాక్ ఎన్ కానీ సెలెక్టివ్ రిపీట్ వచ్చినప్పుడు సో యూ విల్ గెట్ అట్లీస్ట్ అవుట్ ఆఫ్ 14 మార్క్స్ యూ విల్ గెట్ 10 మార్క్స్. ఓకే, సో సీ హియర్ దిస్ ఫ్లో కంట్రోల్ మెకానిజం we have, these are the techniques: stop and wait protocol, go back in, selective repeat ARQ, sliding window. So morning I told ARQ is what? Automatic repeat request. So this automatic repeat request, based on the receiver, we need to send the data. If the data is doesn't reach, the receiver should not give any acknowledgement. Acknowledgement, the packet is lost, the data is lost, the frame is lost. So note just kunamandaro. Okay. So here we have this. Sorry. What subheading is stop and wait. 7 marks question exam point of view. Stop and wait protocol. I'm a marker. Pen. Pen here. See here, stop and wait protocol. The name itself what? Stop and wait. So this what will happen? Sender sending the frame to the home, receiver. Very easy. Here, sender sending the frame to the home, receiver. So what is the use of receiver? Receiver should give acknowledgement. Acknowledgement. So when you give an acknowledgement, what will happen? The sender assume that data is successfully transmitted. Here, this stop and wait protocol, it can transmit the frames either 0 and 1. It can be transmitted either 0 and 1. Either it should be transmitted 0 or 1. The data can be transmitted. When the sender sending the frame to the receiver, the receiver gives the acknowledgement. So within a time, this is the time length. Is it time length? If the timer is expired, within a time cannot receive the acknowledgement, what do you assume that? The frame is lost. మన ఇచ్చిన టైంలో మనకి రిప్లై రాలేదు. So what will is loss? For example, credit card EMI. So credit card, if you want to pay EMI amount, particularly housing loan, any personal loan, any payment, we have some deadline. So within a time, you need to pay the amount. If the deadline is expired, so again, what will happen? I can send to message. So here, within the timeline, if you do any acknowledgement, so was you assume that data is lost. ఏం అర్థం చేసుకోవాలి మనము? డేటా లాస్ అయింది. ఒకవేళ డేటా అక్నాలజ్మెంట్ ఇచ్చిననుకుంటే ఏమనుకోవాలి? డేటా అనేది సక్సెస్ఫుల్లీ సెండ్. And the stop and wait protocol, it can transmit the data either 0 and 1. First point. Second point, sender sending the data to the receiver. If the data is successfully reached, the receiver should give. What is the role of receiver? What is the job of receiver? They can give the acknowledgement. Okay, well, acknowledgement within a time. So, ఏమనుకోవాలి మనము? Frame loss అయింది. ఏమనుకోవాలి? Frame loss అయింది. Frame loss అయితే ఏం చేయాలి? Again, retransmitted. Okay. So here, when EOT, end of the transmission, I don't want to send the data. I want to stop your connection. I want to stop your transmission. Acknowledgement to send to the home receiver. I don't want to transmit the data. So that kind of information we have to see. Sender sending the data to the receiver, we can give the acknowledgement one. అంటే frame 1 అయినప్పుడు దాన్ని should be received acknowledgement. Frame 0, you can so here we got a negative acknowledgement. NAK. అమ్మా గర్ల్స్ వినండి జరా. NAK అంటే ఏంది? Negative acknowledgement. What is NAK? Negative acknowledgement. So I cannot receive a frame. So I cannot receive a frame. Retransmitted. So the sender, what will do, ma? It should be retransmit the data. In just mala retransmission. Okay. Next, frame loss. ఇక్కడ due to noise, see, sender sending the data to the home receiver. Sender sending the data to home receiver due to noise. So noise, due to traffic, due to congestion, due to pollution, the frame will be lost. The frame will be lost means within a time, the frame can. Frame is lost. I don't know where it is lost. Sender అనుకుంటాడు. Sender ఏమనుకుంటాడు? నేను ఫ్రేమ్ పంపించాను కానీ అది రిసీవ్ అయిందా తెలియదు. అక్నాలజ్మెంట్ రాలేదు. ఎక్కడి నుంచి రావాలి అక్నాలజ్మెంట్ మనకు? రిసీవర్ నుంచి రావాలి. ఎవరు పంపించాలి మనకు? రిసీవర్. ఎవరు పంపించాలమ్మా? రిసీవర్ పంపించాలి. రిసీవర్ పంపించలేదు విత్ ఇన్ టైంలో. పంపించాడా? పంపించలేదు. సో ఏం చేస్తాడు సెండర్? ఏం చేస్తాడు? ఏం చేస్తుండు? Again sending the frame. Frame is lost. Again రీట్రాన్స్మిటెడ్. ఏం చేస్తుంది ఇక్కడ? రీట్రాన్స్మిట్. డేటా లింక్ లేయర్ వెరీ వెరీ ఇంపార్టెంట్. వై? బికాస్ వీఆర్ to receiver. Whether the data is correct reach means that is a successfully transmission. If it is contain errors, we need to detect the errors, and correct the errors. So that data can be lost. Well, again, we need to retransmission. These all functionalities comes under the which layer? Data link layer. That's why very important. మన బాడీలో హార్ట్ అనేది పంపింగ్, బ్లడ్ పంపింగ్ very very important. If your blood is pumping, cannot stop, pumping is stop, circulation will be stop. So what will happen? The candidate, the person will be expired. Same way, you are in the data link layer. If you transmitting the data, we cannot transmit the data successfully, we cannot get errors, all this, what will happen? There is no use of transmission. Here, last acknowledgement. Sender sending the frame to the home. Receiver give what? Acknowledgement. Emichindo? Acknowledgement. So when the acknowledgement is lost, lost. So what will happen? Within a time cannot receive the acknowledgement. The sender again retransmitted. So what will happen? They can give the acknowledgement. So this is what? Stop and wait protocol. The stop and wait protocol can transmit it 2 frames, either 0 or 1. So if the data is transmitted successfully, we need to get the acknowledgement. See, next one. Go back in. So go back in. What does the name indicate? Go back in. Go back in. Means what? Ante endamma? Go back in. చెప్పండి. See, sender sending the frame to the submitting is go back end. Under go back end submitting పెట్టుకున్నానా? నోట్స్ రాశారా? Girls, last. Go back end. So see, the go back end, sender sending the frame to the what? Receiver. Then given the acknowledgement is not received. Sender sending the frame 1. Sender sending the frame 2. And sender sending the frame. They given the what? Acknowledgement 3. So 0 is there received, 1 received, 2 received, and 3 is not negative acknowledgement. Why? Because frame cannot be reached. 0 వచ్చింది, 1 వచ్చింది, 2 వచ్చింది, కానీ 3 రాలేదు. 3 reach? No. So what will happen? Again retransmitted. Go back in. So again comes back. Again retransmit the frame. Mala which frame will be transmitted? A frame transmit చేస్తుండు? Third frame. Which frame ma? Third frame. Next which frame will be transmitted? Fourth frame. Which frame will be transmitted? Fifth. So where which frame will be lost? Which frame will be lost? Back. Again retransmitted. Repeating. Retransmission. Retransmission is possible in which layer? Data link layer. Any frame will be lost. Again retransmit the frame. See. Sender sending the frame to the receiver. Receiver give acknowledgement. Sender sending the frame 1. We receive the acknowledgement. Sender sending the frame 2. Frame 2. So what will happen? Should be lost due to connection problem, due to noise problem, due to collision problem, due to any internet problem, any issues. That what will happen? They will be lost. So sender, what will happen? Sender again sending the next frame. So assume that okay, the frame will be successfully transmitted. So అనుకున్నాడు సెండర్, కానీ బట్ ఏమైంది? సెండర్ సెండింగ్ ద ఫ్రేమ్ టు ది 3. ఇక్కడ డిస్కార్డ్ రిమూవ్. వై? బికాస్ వీ కెనాట్ రీచ్ ఫ్రేమ్ 2. మనకి ఫ్రేమ్ 2 వచ్చిందా? రాలేదు. సో రాలేదన్నప్పుడు ఏం చేయాలి? ఫ్రేమ్ 3 రాలేదని ఏం పంపించిండు? వెరీ వెరీ ఇంపార్టెంట్ ఇక్కడ. ఏం పంపించిండమ్మా? ఎన్ఏకే. వాట్ ఇస్ ది ఎండ్? వాట్ ఇస్ ది ఎండ్? నెగటివ్ అక్నాలజ్మెంట్. ఏమొచ్చిందమ్మా అక్కడ? నెగటివ్ అక్నాలజ్మెంట్. అక్నాలజ్మెంట్ అంటే ఏంది? నాకు నీ సెకండ్ ఫ్రేమ్ రాలేదు, మేము సెకండ్ ఫ్రేమ్ రీచ్ కాలేదు కాబట్టి, సో అగైన్ retransmitted. So again, what will happen? They sending the frame to the here. Frame 2 send transmitted, frame 3 transmitted, frame 4 will be transmitted. So this is also very important in 7 marks. Okay. What's happening is selective repeat. Selective repeat. సెలెక్టివ్ రిపీట్ అంటే ఏంది? వాట్ ద నేమ్ ఇట్ సెల్ఫ్ ఇండికేట్. ఆ పేరు చెప్తుంది. ఏం చెప్తుంది అక్కడ? సెలెక్టివ్ రిపీట్ చేయాలి. ఏ ఫ్రేమ్ మన క్లాస్ అయినామో ఆ ఫ్రేమే రీట్రాన్స్మిషన్ చేయాలి. ఏం చేయాలి? రీట్రాన్స్మిషన్ చేయాలి. హియర్ frame 0 will be transmitted to the receiver and frame will be transmitted successfully. Frame 2 will be transmitted. It should be lost. So the receiver can give negative acknowledgement. What is the negative acknowledgement? The frame 2 is not reached. So that sender, what will do? They can resend. ఏం చేస్తుంది ఇక్కడ? Resend. The selective only particular frame which is the loss, that frame will be retransmitted. ఇంతకుముందు ఏమైంది చెప్పండి? ఇక్కడ ఫ్రేమ్ 3 లాస్ అయితే మళ్ళీ స్టార్ట్, గో బ్యాక్ ఎన్, go back in second frame, third frame, fourth frame. But here which frame will be lost? Which frame will be lost? That frame will be transmitted. So draw the diagram. I'm gonna draw the diagram. Diagram draw in. Diagram draw in. Last. I will share you. Completed. Completed. What's happening is sliding window protocol. Exam point of view, they will ask sliding window protocol. sliding. Sliding, the name itself, sliding window protocol. So in the frames will be should be contained in a window. The frame should be contained like a window. So here, see, it should be contained in a window. So these frames, what are the transmit the frames? It should be moved to the forward. Okay, 6 is successful transmitted. 7 is successful transmitted. 1 is successful transmitted. 2 is successfully transmitted. Next frame is 2. Next, sorry, 3. Next is 4. Next, 5. Next, 6. Next, 7. Next, 0. Next, 1. So it should be moved to the like. For example, you can take a clock. So clock 2 is over. Next, 3. Next, 4. Next, 5. The time is like that. Same when sending the frames, it can be moved to the next. And so one more is it will ask piggybacking. Make a note, piggybacking. Okay, note down. 2 marks question అడుగుతారు. 2 marks or 1 mark based on your pattern. So what is the piggybacking? What is piggyback? So piggybacking means that data can be transmitted simultaneously. Data plus acknowledgement. Data plus acknowledgement. Both sender sending the data to the receiver, it can transmit data plus acknowledgement. So both that is called as what? That process is called piggybacking. Data plus acknowledgement should be carried from sender to receiver. That process is called piggybacking. They can ask 2 marks question or 1 marks question. Okay. So 2 marks, 1 mark question, ilanti questions in the second unit means what is data link layer? What are the functionalities of data link layer? Okay. What is frame? What is bit stuffing? What is flow control? What is error control? What is CRC? What is checksum? Okay. This kind of questions in the second unit. What is HDSC? What is the point-to-point protocol? This kind of questions we ask in a 1 mark or 2 marks. In the third unit, what is the MAC? How many channel allocations? What is the pure aloha? What is slatted aloha? What is CSMA? What is the CSMA CD? What are the techniques? Okay. Next, what is the TDMA? What is FDMA? What is IEEE? What is IEEE 802? So this kind of questions, 1 mark question, they are 2 marks question will be asked. Okay. So here they move a direction like this. This will be move. What will which are frame will be sent? That will be moved to the right next direction. Okay. So receiver, those who frame will be completed, that will be come to the out of the window. So next we need to send this all these frames. So this here sliding window protocol. So next slide I will show you what is this example. You can clearly observe. 1, 2, 3, 4, 5, 6. These are frames will in a window. So which frame will be transmitted? 0. ఇక్కడ ఏ ఫ్రేమ్ ట్రాన్స్మిట్ అయింది? 0. నెక్స్ట్ మనం ఏ ఫ్రేమ్ పోవాలి? Which frame will be transmitted? 1. So here, next frame will, what is the frame? 1. 0 already over. 0 already. 0 already over. Next one is already over. So here, they can give the acknowledgement. Successfully transmitted. Or will be 2. Next 2. Next 3. Next 4. Next 5. Next 6. Next 7. So it should be moved the direction, forward direction. So frames are transmitted successfully. We get the acknowledgement. Okay, note on this only up to here. 1, 0, data 1, data 2. Enough. కానీ అంత అవసరం లేదు మీ ఒక్కడి రాసుకుంటే I will share you that notes, but just by tomorrow purpose, I will ask the questions now. Emma. Four. అయిపోయిందమ్మా. Same sender side. That's half of the diagram here. Next here, receiver side. Up to 6 we add to next frame is 7. Heading is channel allocation. Channel allocation. Okay. చెప్పం. Channel allocation. How many types of channel allocations? Last. చెప్పం. What is channel allocation problem? కూర్చోమ్మా. So allocations are, there are two types: static allocation, dynamic. Channel allocations are two types: channel allocation, sorry, static allocation, dynamic allocation. Static. Static means, for in a family, there are 5 members. So there are, sorry, members. In a family, 6 members. How many apples? 3 apples. 3 apples. So 6 members, they want to eat. How? What will half of the apple will be given to the 6 members? So we need to allocate. So okay, first son, half, second, daughter, third, like, so we need to allocate the 6 apples half of to the way the static allocating the static manner. If you want to take FDM, FDM is division multiplexing. Frequency division multiplexing. The multiplexing, what will do? We allocating the frequency. For example, to A user 2, B user 2, C user 2. 2H, 2H. H means what? Frequency. How to measure the frequency? ఎలా మెజర్ చేస్తారు? Bandwidth. H, 50H, 30H, 40H. Frequency. TDM. how can allocate? They're allocating the intervals, intervals. We depend upon the other times we can allocating the like. Same here, static allocation, we allocating n users. N users. N users means number of users. This number of users divided. Number of users divided into n. How many was? N equal sizes. How many sizes, ma? N equal. So 6 apples unnappudu 6 members we need to divide it. 3 apples, what will happen? We need to divide it each half of. Like that, we need to divide it n users and equal sizes. So here, there is only static allocation. What will happen? Sometimes number of users are more. Number of users will be more. So what will happen? It should be doesn't support or doesn't work. What will happen? Sometimes the collision will be happen. See, this division of simple and efficient allocation mechanism here, the only small purpose, large purpose cannot be support. Okay. Make a note, channel allocation. Make a note, channel allocation. Static channel allocation. Okay. F అంటే ఏంటమ్మా? Division. M for what? Okay. TDM అంటే ఏంది? TDM. Time division multiplexing. TDM అంటే ఏంది? Time division multiplexing. FDM అంటే ఏంది? Frequency division multiplexing. So this static allocation, we are allocating some frequency. We need to take some formula. So that formula equal T equal to 1 mu C minus lambda. Okay. This is the formula. T equal to 1 by mu minus C channel capacity lambda. Write down. T for what? Okay. So what is the lambda here? Arrival rate. Lambda per second. Channel capacity. C. C for channel capacity. Okay. F frame length. 1 by mu. Note on this. Okay. క్లాస్ ఎప్పటి వరకు మీకు పోతుంది అమ్మా హియర్ హలో ఏమైందమ్మా బ్రేక్ ఉంటుంది ఉంటుంది కదా బ్రేక్ ఉంటుంది మీకు See here, 1 by mu minus lambda. C for what? Channel capacity. So frame length, transmit the bit per second. And lambda is what? Arrival rate of the frame. So why frame? So we are discussing which layer? Data link layer. So data link layer can be transmitted what? Frames. So here, number of channels, number of users, Tn equal to 1 by mu c minus lambda by lambda n. Mu c minus lambda means here nothing but what? Mu c minus lambda. ఫ్యాకల్టీ లేదు ఇక్కడ. What is submitting is dynamic allocation. Very, very important. Okay, exam point of view. Dynamic allocation. So what is the dynamic allocation? What is the dynamic allocation? Starting means what? Statically allocating the particular frequency or time slots. Now here, the dynamic allocation, we allocated the channel capacity, channel allocation dynamic manner. Which manner, ma? Dynamic manner. So here, this dynamic allocation, we have continuous time, slotted time, and CSM. So we can take aloha. What will take here? Aloha. So aloha how many times? Aloha how many times? 2 times. What are the 2 times? Aloha and slotted aloha. Aloha and slotted aloha. What is aloha? What is slotted aloha? Slotted aloha. Slot and in what is slot? We divide into time slots. So based on the time slots, okay, based on the time slot. So first hour class, second hour class, like slots, first slot, second slot, third slot, fourth slot, fifth slot, number of slots. In slots, what will happen? We need to transmit the data. See here. Any slot, we can use the any slots. Carrier sense. Carrier sense. What is carrier sense? If you want to transmit the data, if you want to carry the data from sender to receiver, whether the channel is free or busy. Whether the channel is free or busy. If it is busy, we need to wait for some amount of time. If it is free, we need to transmit the data. So here, the station can tell the channel is busy before try it. So we need to wait some amount of time. Then we need to transmit the data. If it is free, we can transmit. See, this is the pure aloha and slotted aloha. Okay. Pure aloha is the one of the scientist name. They defined there are 2 types of alohas, pure aloha and slotted aloha. Pure aloha lo emaitadi, slotted aloha emaitadi check cheskondi. So here, frame 1 will be transmitted, frame 2 will be transmitted. Okay. Same time, if you want to transmit the both the frames, what will happen? The collision will be happen. ఇద్దరు ఒకసారి పోయినప్పుడు ఏమవుతుంది? The collision will be happen. Means, for example, 2 bikes at the same time. ఏమవుతుంది? Accident అవుతుంది. Same way, the 2 frames will be transmitted at the same time. The collision will be happen. Here, this is the collision time. So if you same frame, this frame, for example, overlap. ఏమైతుంది? Overlap అయినప్పుడు collision అవుతుంది. Overlap to allocate slotted. We need to allocate. For example, we are transmitting the frames. Depending upon the time intervals, will be slot. For example, same slot, it's the same user, A and B and same slot ఇచ్చిన. So to avoid that collisions, we need to sometimes here collision will be happen here also. ఎందుకంటే A is the user is the B user C D E F. Same A transmit the same slot and B also slot same times. What will happen sometimes? ఒకసారి sometimes will be happen. Okay. So note on this. Pure aloha, this is, and slotted aloha, this is indicate time. Okay. See. Note on this. So అయిపోయిందమ్మా. Completed. Okay. Here, so this is the pure. This is added alaha. So pure alaha, we are allocating some time in random time. So we need to transmit sometimes the both frames are happen at the same time. The collision will be happen. Here also the same slots will be happen. Two frames. Sometimes here collision will be happen. But better to this slotted alaha. The throughput is 36%. This is 86. Sorry, 18%. See. The pure allow versus slotted allow. Okay. In this, if you want to use the slotted allow, G equal to E to the power of minus G, and pure allow equal to G to the G into minus 2G. I will show you 1 minute. One by E equal to what is the value? 1 by E. 1 by E. What is the value? Tell me. Use calci. Use phone. Tell me. 1 by E. Zero. 0.36. That is the throughput, that is output of the slatted aloha. If we take pure aloha, 1 by 2e. Why? Because G equal to C here. G equal to, sorry, S equal to GE to the power of minus 2G. S for throughput. Throughput, how much accuracy, how much that the performance of that channel it should be give. S equal to GE minus 2G. If equal to 2E, how much? Check it, 1 by 2E. 0.18. So 18%. ఎంత అమ్మా? 18%. ఏది 18%? What is the 18%? What is the 18%? చెప్పండి అమ్మా. ఏ అలో 1.18. 18% ఏంటిది? 18% ఏంటిది? ప్యూర్ ప్యూర్ అలో ఎంత? స్లాటెడ్ అలో ఎంత? 36. So 18% collision will be happen. It is the 36% throughput. Output will be comes. So the collision will be less. ఎందుకు less? Why less? Why less? Why less ma? Slatted. Okay. So once you give a syllabus, any pending? Okay. Syllabus check. ఇంటర్నెట్ ఇక్కడ వరకు ఉందా? అంతేనా? ఓకే. అమ్మ సాఫ్ట్ కాప్ లేదా? Okay. So very small topic. So this will be wind up a last topic. Okay. Okay. Actually, last we have IEEE. Honor allocation protocol. Okay. So by tomorrow, so what are the pending topics? Error correction, error detection, HDLC. The next one more is CSMA. So by tomorrow, morning session first off, we need to check the error correction, error detection will be solved. So after that, HDLC, then lunch break. After lunch break, we'll go for the CSMA and what you call TDMA, FDMA. So we are complete the third unit also. So by you should be focused in the second unit, somewhat difficult. Why? Because we have error, design issues of data link layer. మీరు చదవాల్సింది ఏముంది design issues of data link layer. Okay. Then second is what is the framing. Third, flow control mechanisms. Flow control mechanism though stop, go back and selective repeat. These are comes under the flow control. Next, error correction, very, very important. Error correction, error detection, very important. Error detection and error correction. CRC and a problem untadi. That problem will be asked for the exam point of view, either 14 marks or 7 marks. Direct problem. Only problem we need to solve. If you solve the problem, you will get 7 by 7 marks. Why? Because if the remainder is 0, data is accepted. So you solving the problem. If you get a 0, automatically they will give a 7 marks. The CRC is very, very important. Next, in that unit, HDS and a topic untadi. That is the last topic. That is also important. Next, coming to fourth unit. Fourth unit is easy. You need to learn. MAC. What is the MAC? How many types of allocation? Static allocation, dynamic allocation. Dynamic allocation, the pure aloha ante endi, slotted aloha ante endi. Pure aloha, what is the throughput? What is the slotted aloha? Throughput. So 1 by E ante slotted aloha, 1 by 2E ante pure aloha. So 1 by E equal to how much? What is 36%? 1 by 2E ante pure aloha, that is 18%. So that is should be you have to remember. Next, CSMA. Carrier sense multiple access. So carrier sense multiple access. Again, there are two mechanisms. CSMA, CSMA, collision avoidance, collision detection. Okay. Next, time division multiplexing, TDMA, FDMA, CDMA. So that topic will be tomorrow. Next, we have one more topic very, very here. IEEE. Okay. What is IEEE? IEEE. చెప్పండి అమ్మా. IEEE. IEEE. Institute of Electrical Electronic Engineers. So here, the Institute of Electrical Electronic Engineers, they propose one model. So here, that comes under the 802. The standard IEEE 802 will be some standard. In that standard, we have some versions. Chala versions ఉన్నాయి. Amma here. Version 1, version 2, version 3, version 4 ఎలాగానో సేమ్ 802లో 802.1, 802.2, 802.3, 802.4, 2.5, 802.6, 802.7, 802.9, 10, 11, 13, 802.11. So it comes under the wireless LAN. So these all comes versions. So here, according to your syllabus, This all are there. Only one is there. That is what? So your syllabus only this will be there. Only this table will be there. Okay. So I will show you just for understanding purpose. 802 point we can use for the logical link control protocol that comes under the data link layer. 802 point Ethernet. What is Ethernet? Anyone? Ethernet. Ethernet and చూశారు ఎప్పుడన్నా? Ethernet. Ethernet అంటే ఏందమ్మా? Ethernet. Ethernet. What is Ethernet? ఏందమ్మా? Network. What is Ethernet? Connecting. ఎప్పుడైనా చూసావు ఈథర్నెట్? చూడలేదా? గూగుల్లో చూసిన. వాట్ ఈస్ ఈథర్నెట్ మా? ఈథర్నెట్. ఈథర్ అంటే సార్ ఈథర్నెట్ nothing but ether. Ether is nothing but wire. It's a wire. So, do you know NAC? NAC and ESA? NAC. NIC. తెలియదా? Network Interface Card. What is NAC? Network Interface Card. Network Interface Card ఎందుకు యూజ్ చేస్తారు? LAN card. Network Interface Card nothing but what? LAN card. What do you call? LAN card. LAN card అంటే తెలుసా? సో మన ల్యాప్టాప్ ఉంది ఫర్ ఎగ్జాంపుల్. దిస్ ఇస్ మై ల్యాప్టాప్. So here we have port. We have a port there, back side. LAN port. A LAN port లో ఇప్పుడు put a wire. Ethernet wire. That is called is Ethernet. Ethernet nothing. NSC card అంటే ఏంది? Network Interface Card. LAN card. So every LAN card should be have unique address. ఏముంటుందమ్మా? Address, unique address. So if you want to support the network, we have a network interface card. So that is network interface card nothing but what? LAN card. What is the MAC address? MAC address అంటే తెలుసా? MAC, MAC. MAC address is nothing but physical address. What is the address? Physical address. 48 bits. How many bits? 48 bits. IP address, how many bits? Internet. What is IP? What is IP? Internet protocol. How many bits are there? 32 bits. How many bits, ma? How many? So IP address is also called as logical address. Which address? Logical address. Exam point of view placement law. Exam technical side. Written test written in the written we have aptitude. Then what will happen? Technical concept. What is the logical address? So logical address is nothing but what? IP address. How many bits are there in IP? 32 bits. Okay, what is the MAC address? Physical address. How many bits are there? 48 bits. So what is Ethernet? say ether. It's a ether, nothing but cable. So here, you know, router, wireless LAN. What is the router? Wireless LAN. So wireless LAN 802.11. 802.11. That is we will use it for what? Wireless LAN. Wireless LAN. So here some standards will be there. 802.2, 802.3, 802.4, 802.5, 802.6, 802.7, 802.11, 13, 14, up to 15 is there. So here, this 802.3 used for what? Ethernet purpose. 802.4 used for the token bus. 802.5 used for the token ring. Token ring means ante they have a structure. Token bus we have a structure. Token ring have a structure. How to connect the Ethernet, that will be have. So here, according to your curriculum, your syllabus, see, in your syllabus, we have this. అమ్మా వినండి సిలబస్ లో 802 పాయింట్ lands. In that we have a topic, individual topic, like 10 base 5, 10 base 2, 3, 10 base F. Okay. What is the 10 base T? What is the 10 base 2? What is 10 base F? These are standards. Ethernet standards. So Ethernet standards. So if you use 10 base 5, what is the 10? No, what is the base? What is the 5? చెప్పండి. Anyone? 10 అంటే ఏంది, బేస్ అంటే ఏంది, 5 అంటే ఏంది? చెప్పండి అమ్మా. 10 base 5. ఎగ్జామ్ పాయింట్ ఆఫ్ లో డిఫైన్ 10 base 5 అని అడుగుతాడు. ఏం చేస్తారు అప్పుడు? 1 మార్క్స్ ఆ 2 మార్క్స్ క్వశ్చన్ లో 10 అంటే ఏంది? ఎనీవన్? 10. 10 is speed, base is the signal, baseband signal, 5 is the distance. 5 is what? Distance. 5 is what? 500 meters, 200 meters, T for twisted pair, F for fiber optic. F అంటే ఏంది? Fiber optic. T అంటే ఏంది? Twisted pair. But 10 plus 5? 10 for speed. 10 ఏందమ్మా? Speed. Base. Base is what? Signal type. Base is what? Signal type. What is the 5? Distance. 5 is the what? Distance. So it should be covered up to 500 meters. 2. What is the 2? 200 meters. What is the T? T అంటే ఏందమ్మా? T అంటే ఏంది? Twisted pair. T for what? Twisted pair. What is F? Fiber optics. See, maximum segment. Maximum segment. How much segments? 500 meters. 10 plus 2, approximately 200 means 185 meters. The twisted pair how much distance? 100 meter. Fiber optics more. 2000 meters. 2000 meters will be support. Okay. And how many segments will be connected? Have connected 100. Here how many connected? 30. How many connected here? 1024. How many here? 10. Okay. Should we have a high speed? It should be give a more number of devices will be connected. Twisted pair ఎప్పుడైనా చూసారా మీరు? ఎలా ఉంటుంది twisted pair? ఎలా ఉంటుంది వైర్? ఎగ్జాంపుల్ ఎక్కడ యూజ్ చేస్తారు twisted pair? twisted pair ఎక్కడ యూజ్ చేస్తారమ్మా? ఎక్కడ యూజ్ చేస్తారు? హ్మ్? అమ్మా ఎక్కడ యూజ్ చేస్తారు twisted pair? Telephone lines, you know, cable, telephone wire. So we can use, for example, like this. Okay. So this is the very thin line. Okay, we can use phone connection, landline mobile connections. We can use the twisted pair. Coaxial cable ఎక్కడ యూజ్ చేస్తారు? Coaxial cable, coaxial. Coaxial cable. ఇంట్లో మీరు రోజు చూస్తారు డైలీ after completion of your college you will go for ఎక్కడ యూజ్ చేస్తారు టీవీ where did you use TV in the TV connection we can use which cable here coaxial cable okay so these are advantages of this 10 base 5 we have you can use cable so no need to we can use here we have to use cheap why because less cost will be there so here we need to connect more devices more purpose we have to use fiber nowadays we are using what 10 base F so we have one more topic is there 100 GB what is the topic three mamas కాదమ్మా జిగా ఈథర్నెట్ fast ethernet and giga ethernet what is fast 1 GB 10 Gbps will be there 10 the fast ethernet will be how much speed 100 Mbps how much speed ma 100 Mbps here 10 giga speed more speed the more speed will be give what giga ethernet so by tomorrow we'll discuss fast ethernet and giga ethernet okay so 2 minutes break okay Sorry. Okay. See here, 10 base T, 100 base T. This all comes under the twisted pair categories. So Ethernet, we have some standard. So what are the standards are there? First one is 10 base 5, 10 base 2, 10 base T. Okay. Next 10 base F. 10 for what? Only speed. 10 is what, ma? Speed. So base is what? Signal. So next one is either distance. Okay, speed, signal, distance. So instead of 10, we'll go for what? 100. We'll go for what? 100. So 100 plus T, 100 plus 2, 100 plus T. So after that, we'll go for the fast Ethernet, 100 Mbps. After that, we'll go. Nowadays, we are using giga speed. Which speed you are using here? Giga speed. So just now, you learn only 10 base T. 10 base T means 10 for speed, base for signal, T for distributed. So we also use for 100 Mbps. How much? 100 Mbps. So 100 Mbps speed will be used for the twisted pair. See here, bandwidth 100 Mbps, so 10 Mbps, 100 Mbps, 1 giga Mbps. So now coming to here, the last topic here. See, I will wind up your session. Listen, Magas. The last topic, fast Ethernet and giga Ethernet. So fast Ethernet, what is the speed will be used? 100 Mbps. 100 Mbps. So giga, 1 giga is there, 10 giga will be there. So 10 giga, so here we can use what is the speed here? 1000 Mbps. 10, 100, 1000. That comes last one is what? 1000 giga speed. Okay. Fast Ethernet. Last one is what? Giga Ethernet. So nowadays we are using what, ma? Giga Ethernet. Sir, question was 10 base standard Ethernet undi kada, fast Ethernet undi kada. What is the Giga Ethernet? Why we use? ఎందుకు యూజ్ చేయాలి? Okay. So here, if you want to transmit the data long distance with a base signal with a speed, we can use the cable type. Cable, based on the cable, we need to transfer the data very fast. So if you take a simple example, in your home, the bikes are there, different types of bikes. Okay, Pulsar bike will be there, Unicorn bike will be there. Okay, Passion Pro bike will be there, Honda company. So means Hero company, Honda company, Bajaj company, TVS company will be there. And same way, your cars, different types of cars will be the Kia Motors or Baleno or Maruti. Okay, bench, the different types of categories of the cars will be there. So simple example, every home, we have a bike. So here, every home should be contain a bike. Like if you take a Pulsar bike is there, Hero Honda bike is there. Earlier, 100 cc will be there, 150 cc will be there, 185 cc will be there, 225 cc will be there. What is the cc? Engine capacity. So engine capacity, if we take 100, 150, 180, 225, so which is the vehicle will move fast? The speed, the pickup. Which vehicle will be there? Bike లో 150 cc ఉంటుంది, 185 cc ఉంది, 225 cc ఉంది. ఇంజన్ కెపాసిటీలో ఇప్పుడు ఎవ్రీ హ్యూమన్ హ్యావ్ ఏ మొబైల్, స్మార్ట్ మొబైల్స్. మీ దగ్గర ఫోన్ ఉంది. సో మీ ఫోన్లో కొంతమంది దగ్గర 8 మెగా పిక్సెల్ ఉంటాయి, కొంతమంది 16 ఉంటాయి, కొంతమంది 32 ఉంది, కొంతమంది దగ్గర ఓకే 64 ఉంది, 32. సో డిఫరెంట్ టైప్స్ ఆఫ్ కెమెరా క్లారిటీ. విచ్ ఇస్ ద క్లారిటీ హై? విచ్ మొబైల్ విల్ బి హ్యావ్ క్లారిటీ? 8 మెగా పిక్సెల్, 16 మెగా, 32? 32 megapixel. So if you have the megapixel 32 megapixel phone, they can give a good clarity. Same way, bike also 150 cc, 185, 225. The engine capacity 225 is the high capacity. So the speed will be more. The same way, the signal, if you want to transmit the data more fast, we need to have a data speed that we can also high speed is what? Giga. Standard kanda, fast kanda, what is the highest? What is the highest ma? Giga. Giga speed will be more. అర్థమైందా? స్టాండర్డ్ ఇథర్నెట్ ఉంది, ఫాస్ట్ ఇథర్నెట్ ఉంది, జిగా ఇథర్నెట్ ఉంది. విచ్ ఇస్ ద ఫాస్ట్? Ethernet will be fast. So here 10 Mbps will be there, 100 Mbps will be there, 1000 Mbps. 1000 Mbps is the more speed. The fraction of data. What is the PPS? PPS and తెలుసా? How to measure the oil? Oil. Kgs అంటారా, లీటర్స్ అంటారా? లీటర్స్ అనే వాళ్ళు రేజర్ హ్యాండ్. ఆయిల్ లీటర్స్ ఉంటుందా, కేజీస్ ఉంటుందా? ఒక్కరు, ఇద్దరు, ఇంకా ముగ్గురు, నలుగురు. Okay. So we can weight will be measured by kgs. Okay. No signal. ఒక్క నిమిషం ఇప్పుడు వస్తుందా? Okay. So here, heroes morning, what we will discuss? Morning and afternoon. So afternoon class is, so design issues of data link layer. Okay. So design issues of data link services provided to the upper layer. Upper layer nothing but network layer. Second is framing. Third one is flow control. Next one is error correction mechanism. Okay. Next last one is tunnel allocation problems. So 5, 6 problems are we have to identify. First one is provided to the service to the upper layer. Second one is framing. Third one is error correction or error detection. Next one is flow control mechanism. Last one is channel allocation problem. So this topic is over. Next, coming to framing methods. What are the framing methods? First one is character count. First one is character count. Second one is byte stuffing or first one bit stuffing. Second one is byte stuffing. Third one is byte stuffing. Fourth one is physical enter code. So four techniques. Once again, I'm repeating. Character count. Character count. Second one is byte stuffing. Third one is bit stuffing. Next one is physical and monster code. So these are four techniques comes under the which technique? Framing. Next, flow control. So in the flow control, what are the flow control? Stop and wait, ARQ, go back in, selective repeat, sliding window protocol. So this topic are we have to learn. So stop and wait, ARQ. So we can transmit the data either 0 and 1 frame. 0 frame or 1 frame. So for example, if you within a time, if your receiver is not, receiver cannot give any acknowledgement, means what will happen? There is the frame will be lost. So what we'll do? We can again resend the frame. So for example, the frame sending to noise problem, then it should be damaged. So within a time, cannot get any acknowledgement. What will happen? Again, retransmit the frame. So receiver should not give any acknowledgement. What will happen? Again, retransmit the frame. So go back in. So where the frame will be lost, again will be retransmitted. So what we'll do, ma? We need to retransmit the frame. Selective repeat and any selective repeat. First frame is there, second frame is there, third frame is there, and fourth frame is there. First frame will be successfully, second frame will be transmitted successfully, third frame will be damaged. Third frame will be damaged, and fourth frame will be transmitted. But the selective repeat, which frame will be damaged? Third frame. A frame damage is manako third frame. So that third frame again retransmitted. That comes under the selective repeat. Next, sliding window protocol. Sliding window protocol, the frame should be contained in a window. They don't have a window. So the frame will be sending, it should be moving to the next. It is moving to the forward or it moving to the next. It moves side. So next, for example, frame is transmitted. Then they go for the next frame. Next second frame is transmitted. They go for the third frame. Next to fourth. Next to five, the window will be to the positions. Okay. In the piggybacking means what? We can transmit the data both. How will be transmitted? Data plus acknowledgement both will be transmitted to the sender to receiver. Next one is what do you learn? Channel allocations. So channel allocation, there are how many types, ma? 2 types. Static allocation, dynamic allocation. The static allocation, we allocate the number of users, number of frequencies. Number of users, number of frequency. That is nothing but FDM. What is FDM? Frequency division multiplexing. What is FDM? Frequency